So part B of this problem is to complete the implementation of curry, a higher order procedure that is called repeatedly on a non-negative integer num_args, and then a procedure f. And it returns a curried version of f that, when repeatedly called num_args times, returns the result of applying f to those arguments. And you can assume that f takes num_arg arguments. Okay. Also notice that as a special case, curry of 0f calls f on no arguments, which is the equivalent of just evaluating f. So right off the bat, this kind of gives me the indication of like a base case of some sorts, because they're telling us, oh, once num_args gets to 0, we know how to evaluate that. And then they have a hint that the built-in apply procedure takes a procedure f and a list of arguments s and applies f to the elements of s. And we can think about how we can use that function maybe in our implementation. So because this is a pretty complicated problem, let's just run through an example with a doc test to make sure we understand what they're asking for. So in the first doc test, this part of the code that I've selected here, that is our actual function call onto curry, and then the subsequent calls on 4, 5, and 6 are all kind of these curried calls. So when you call the call to curry on 4, that returns another function. When you call that function on 5, that returns another function. And then finally, when you call that function on 6, then we get to our base case where we're actually adding all of our curried elements thus far, and that evaluates to 15. So that's just something we need to keep in mind, that we're repeatedly returning functions until we get to that very last num_args call, and then we finally evaluate to our value. So now let's just take a look at the skeleton that they've given us. So this is a little bit complicated because we do have a helper function. Basically, you have the define curry, which calls the helper function curry helper. So just as a refresher, the main reason when we would ever want to use a helper function is simply if we need to store more information. So this curry function originally only takes in num_args, but we need to have a way to kind of save the function that we're supposed to curry on each time, which is our f function. So that's why we essentially need a helper function that takes in num_args and f, or otherwise known as g in this term. But yeah, so now let's look at what the actual curry function is. Essentially, it's just returning another function, right? Which is good because, like I said before, all of these calls on curry are going to return functions until you get to the very last call. So you don't really have to fully understand what all of this is doing, but essentially what it's doing is it's returning a function that calls curry helper with that saved function that you want to curry on. So we're saving that f, or otherwise known as g. That way we can kind of remember it as we go through our multiple curries. But for the purposes of this problem, what we really need to focus on is just the helper function, because that's what's left for us to implement. So this helper function, and it looks like it follows the standard pattern of recursion where you have your if-else being your base case and your recursive case. So let's focus on the base case first, because like I said before, they've kind of given us a hint towards what we should write for this. So they're saying, as a special case, if curry of 0 on f calls, if you call curry on 0 in f, that essentially calls f on no arguments, which is equivalent to evaluating just f. So essentially, you're just going to be calling g on nothing, so nil. But there are a bunch of ways to write this equivalent expression. So you could also say, for example, just calling g on the empty list. That's equivalent. Another slightly more complicated way to do it is by using the apply, which is the procedure that they've given us in the hint right here. So you could basically call apply on g and then list nil. know. And the reason why you need this extra list is because the apply function has to be called on a list. So now moving on to the recursive case, which is quite a bit more complicated. But basically, as you can see, you're returning another function, which is why you have the lambda x here, which calls curry helper on num args and another argument that we have to implement. So you're subtracting one from the arguments, which is good because every time you curry, you want to have one less iteration left. And b is essentially the version of f, so a version of f that already takes into account that extra iteration of currying. So what I mean by this is, remember that our function signature, I'm just going to erase some of this because it's getting a little bit messy. Yeah, but our function signature, curry helper, takes in two arguments, num args and g. So this blank b has to be a version of g, or otherwise known as f inside our kind of problem statement. But f and g, essentially the same thing here. So basically it has to be a version of g. But what is g? G is a function. So we have to make sure that this thing that we pass in here has to be another function. So that means that we're going to have to be writing in lambda here. So lambda is going to take in one argument because that's what g is. It's a one argument procedure. And then now we just need to figure out what is this function actually doing. So in order to figure that out, let's take a closer look at what they've given us for this recursive call. So they've given us that we're returning a lambda that takes in a parameter x and then calls curry helper on blah blah blah. So the important thing is, what does this x represent? Well, what it represents is essentially these different numbers that you eventually call. So remember that we're taking in one value. So when you're calling this curry function on a 4 is going to be your x here. And then when you call it again, 5 is going to be your x here. And when you call again, 6 is going to be your x. So they're essentially the next kind of arguments that you put in your curried call. So now with that in mind, what do we want our lambda expression to do? Well, inside our doc test, you're essentially calling f or g on what you have so far and that new x parameter that you're passing in, or x argument. So in order to do this, we're going to call g on the list. So I'll just write list x s. So the reason why we have list, you could also use cons here. I think that's what the answer key uses. But the reason we have this list is because you want to call g on your x argument, which is like the 4, 5, 6, and what you have so far, which is stored in a list s. So this is new arg what we have so far. And of course, I could have named this variable s anything. So when I was writing out the lambda, I could have named this like hello, right? I just named it s for further clarity because this is really representing the list of things that we had called so far, which in the problem they say like the list of arguments s, so s. But yeah, so that was this problem. If you feel like this problem, well, especially this recursive call, was like super confusing and there's no way that you could have gotten it on the exam, don't worry, most people did not get it on the exam, including me. So I remember, I think they actually gave 4 additional points on the final because so few people were able to do this part, and like one part in the next problem, which we will do in the next part, so stay tuned for that. But yeah, so this was the problem. I'll just write out the answers just for completion. So this was lambda s and then G list X S. And yeah, that was problem 4b.